Here we have like a simple like 8-bit CPU. So how exactly it works is so all of these so in the last video you would have seen my 8-bit CPU's addition operation using manual inputs. Here what we do is here I've made it into a single block. So all you see here is the entire unit. So we are at the topmost level. So each thing is like made into a single like a block so that it'd be easier for us to figure out what exactly we are getting as outputs. So here we'll be performing a simple multiplication operation of numbers 5 into 5, which will be stored in the register, and you'd get the answer 25, but then 25 won't be shown as it is. You'll get the answer in terms of hex. So the representation of 25 in hex would be your answer here. So, in order to begin with how the CPU actually works, let me just tell you how it works. This here is our external RAM. So, initially, before starting our program, we'll have to manually input the given data into the RAM so that the CPU can process through the entire RAM and take in inputs that is based on the program here that we have. It's a simple multiplication operation. So what we'll be doing here is I'm going to load data into the external RAM, and this bus here will count the data which is present inside throughout the RAM from 00 to FF. So all this data will be gone through the bus here. So once we run our program of multiplication, it will be able to automatically choose the register values that have been stored, that is 5 and 5, and then it will perform the ALU operation that we could see further in the program again. So first, show you how the loading works. So initially we go reset the simulation, which means there's nothing here. So what we do is first we have to load. So once you load that the bus is turned on, and we reset so that all the data from here is being cleared. Press reset. So as you can see that all the data here is cleared now. And we turn on the memory address register through which the external RAM is accessed. What I'm going to do here is I'm going to add in the content, edit content. So I'm going to add my own file of data that I've already made up. So it's called my sim. You see here it is. So as I load in data, you can see here all the data is loaded as in hex values. So we now close this, and now you can see that the external RAM has this data here. So what we do is we go to the tick frequency, which means that how fast the program runs. So here I have 4.1 kilohertz set. That is the default for my laptop here. You could set it to any frequency you want. So the lower you set it, you'll be able to see the operations more clearly of how the data is being added into the external RAM. So what we do is here we set a frequency. I'm going to set 4.1 kilohertz so that it run really fast. And when I do a stick enabled, the clock is going to start seeing that all the data will be gone through from 00 to FF in the external RAM. You see that right now. As you can see that it was a very fast operation. The clock's still going on, and once we reach FF, we can just turn on the tick again. So clock's back to normal. And with this, we have now we have completed like the entire. We have gone through the entire data through the external RAM that was stored. Now what we do is to bring the clock back to its initial state, which is 0100. So as you can see, like it should be back to its initial state, which was in the initial state. And now we can turn off this, and we don't do anything else. Now all the data is loaded into the external RAM and it's gone through the bus. And now the data is stored in the RAM. Now what we do is we just have to enable. We just have to just enable the clock again, and then our ALU operation will go through. As you can see, our ALU operation goes through really fast. So I'm not actually like, maybe I could show you how exactly it processes through. Now that the operation is done, that it's constant now, but it's a very fast operation. So when you want to like go through each and every step, you could also like tick once, which means like every step can be looked into the CPU or to the subunits. So you can see it through here. now our operation is done. And how do I know it's done? You see that the end flag is now red, which means our operation is done. You can turn off the clock. I can see here my operation for 19 is my result, which means like 5 into 5 is 25. And in terms of hex values, it is represented as 19. And that is my final result. So this is a simple 8-bit CPU arithmetic operation that is done, a multiplication operation that is done in like an 8-bit CPU. Thank you.